Hi there. Could I have everyone's attention, please? Hello. Thank you for all coming this evening. I'd like to welcome you all, our students, faculty, and friends of the School of Architecture and Design at NYIT. As most of you know, my name is Judith DeMaio, and I am the Dean of the School of Architecture and Design at NYIT. And before we introduce our distinguished guest, I would make the following comments. Most of them you know. Please remember, and that will include me, to turn off your cell phones. And number two, for those of you who are registered architects and or AIA registered architects, there are 2 forms out there for you to sign to collect your learning units, 1 unit per lecture. They add up, thank God. I'm laughing because one of the professors who taught me my last 8-hour series for 8 credits is here tonight. So, hi there. So please put down your membership number and your phone number if you don't have your membership number, so we can all have our special events coordinator make the links and the connections. Tonight's lecture is the second in the second of our fall 2015 series. Our lecture last week was by a faculty member, Esteban Bieta, and tonight, again, we will be having a lecture by our esteemed full-time faculty member, Nader Vossoughian. Our next lecture, after this, the third lecture, will be on October 10th. Everyone should have gotten a save the date card. I'm not sure why we don't have any out front, but you can go onto our website, and that lecture will be given by Ron Blitch, and it will be in Old Westbury at the D. Seversky Center. And this is our lecture sponsored by the Friends of the School of Architecture and Design, our fabulous, wonderful alumni organization, and they sponsor one of our lectures every year, and that one tends most often to be in Old Westbury so that we flip-flop between campuses for our students. Our fourth event will be on November 3rd, where Jake Gorst and Kirk Brown and Gayatri Mulapudi will present the film Modern Tide, Mid-Century Architecture on Long Island at our auditorium in the next block, the NYIT Auditorium on Broadway. It's, I think, on 61st and 62nd. Our final lecture for the series will be Arno Brandauer and Sam Chemaev on Monday the 16th, and that lecture will be at Steelcase, which is on the corner of Columbus Circle, and we're hoping that you will all make all of these lectures if possible. I'd like to thank our special events coordinator, Jennifer Mitchell. I'd like to thank our AV person in charge for helping us out tonight, and I'm sure there are many other people that we should thank. But what I'd like to do, as most of you know, I never want to dwell on people's accomplishments, which we put out on a chair as their CV, not so much because I don't want to, but because it takes too much time out of the actual lecture and the person who should be speaking. And I shouldn't be taking up too much of the time. But I met Nader, I don't know, maybe 7 years ago? Hello, Nader. Huh? A decade ago, okay. I met Nader not 10 years ago, but a decade ago when we hired him to be on our faculty as a junior professor. He has since become tenured. He has a Ph.D. He speaks German and has spent the last year and a half, I think maybe 2, in Berlin, predominantly Berlin, working on his next book. Is that true? There are many books that have been published, even got written up in the Times, his other book. And also I've had the pleasure of running into or spending time in our summer programs in Berlin and spending time with my Professor Altwicker, who runs those programs, and Nader has often been there. I also rendezvoused with my summer programs in Rotterdam and got to know Nader and his whole family much better. Again, I don't know why I'm in a funny mood, but Nader rode me to the house, the Schroeder house, Gerrit Rietveld Schroeder house, on the back of his bicycle, and we got lost. So In any event, I want to welcome Nader. Thank you.
Thanks, Judy, for the kind introduction. I'm going to be presenting some material that I unearthed during the course of my sabbatical this past academic year. My wife and I and our 3 kids had the great fortune of being able to spend our year in Berlin, and it was an incredibly stimulating and fruitful and inspiring time. I want to thank Judy as well for the kind introduction, as well as for supporting my sabbatical leave, and Jennifer Mitchell. Where's Jennifer? Jennifer has been really instrumental both in putting this together. She invited me to offer this lecture, but also, very importantly, last week, a number of students and I had the great opportunity of being able to visit the American Society, the ASTM, the American Society of Testing and Materials, which is a major leading standardization center for the construction industry here in the United States. It was very educational, and it's really thanks both to Judy and to Jennifer that bus transportation was possible for that. So thank you very much. And I think that some of what I'm going to be talking about in this lecture also draws on that experience last week. I'm going to begin with this quote. If law is the currency of government, standards are the currency of international organizations and multinational enterprises. It's by Keller Easterling in a book that she published, actually not this year, but last. She's proven to be very influential for this study, and I had the great fortune to be able to study with her as well a few years back one summer. This presentation is going to be dealing with the organization, which is also to say the rationalization of intellectual labor in the 20th century. So what I'm going to be talking about is both how the reorganization of the workplace that took place over the course of the 20th century, both in the sphere of manufacturing, but most especially also in the sphere of what we call intellectual labor, particularly in the architectural profession. I'm going to be talking about standardization in architecture and its relationship to the geopolitical ambitions of Nazi Germany. I'm also going to be talking about standardization, the standardization specifically of grid systems in the design process. When I'm talking about standardization, I'm going to be talking about it in a sense that's probably not especially familiar to many of you all. In the industry, there are 2 types of standards. One is called performance standards, and the other is called procedural standards. And performance standards, as we learned last week, tend to be quantitative. Like here, you want to know the wind resistance potential of a glass pane. There are standards built around that, and those tend to be dominant in the U.S. construction industry, as we learned last week through our visit at ASTM. In most of the rest of the world, by contrast, procedural standards are actually much more important. What procedural standards tend to do is they try to ensure quality control. Quality is a very important objective where standards and standardization efforts in much of the world, but most especially outside of the United States, is concerned. And this is the history of this, in a sense, is what I'm going to be talking about this evening with you all. As a bit of context, what I want to emphasize is that, and I think this is one of the important revelations of my research, that the history of standardization, particularly in 20th century Europe and in Germany most specifically, is intimately tied to the history of the use of forced labor and slave labor in Nazi Germany. The Nazis really introduced 2 of the most important architectural standards of the last century, and it was an important revelation for me to learn how they informed the construction efforts that took place during that period. one has to bear in mind that a good deal of mainland Europe was occupied by the Germans between around 1939 and 1945. France, the Netherlands, Belgium, Poland, parts of the Ukraine as well, in addition to Austria, which was actually annexed. Forced labor was also an important part of that economy. In 1944, 25% of all workers in the Reich, in the German Empire of the period, were actually either forced labor or slave labor, because many of the able-bodied males who were German were off fighting the war. In the construction industry, moreover, in 1944, there were roughly 300,000 workers who were either forced labor or slave labor. Now, I'm going to be exploring the importance that this history plays to the history of standardization in architecture in Germany. But in order to do so, I think it's important first to step back a little bit further in time. And to do that, I'm going to be talking about early efforts to organize intellectual labor in the German-speaking world. And I'm going to do so by way of a particularly important standard that I think has been proved seminally important to the history of architecture's relationship to standardization. The standard I'm going to talk about is DIN 476. This magazine, the Neue Zürcher Zeitung, the New Zurich newspaper, described it as the standard of all standard. It was introduced by this gentleman here. His name is Walter Porsmann. He was an engineer, and he was an assistant to a guy named Wilhelm Ostwald, who, in addition to being a Nobel Prize-winning chemist, helped start a group called the organization, called The Bridge, and they devoted themselves to the organization of intellectual labor. This is a photograph of Ostwald here. Ostwald's central insight, I think, was that if one wants to organize, one should begin with the unification and coordination of the most routine, common, and least contemplative activities and functions. And essentially, what he argued is that in order to organize, and hence one has to standardize, and in order to standardize the modern office, one should begin with the sheet of paper, the common sheet of paper. And this brings me to DIN 476. DIN 76 is a standard sheet which the German Institute for Standardization introduced in 1922, and it essentially adheres to three principles. All paper sizes under this standard are based on the metric unit. The largest paper size under this system is known as A0, and it's a poster-sized sheet of paper. What I'm showing you here is an A4-sized document. It's the equivalent of our 8.5 by 11. And this brings me to the second rule that DIN 476 dictates, and that is that all paper sizes maintain the same aspect ratio at all sizes, and that is 1 to the square root of 2. And the reason for that is so that when you reproduce a document at a larger size, then the proportions, you can transfer the proportions. They're not going to be distorted at different scales. A third rule that makes this such a compelling standard is that all of the standards are interconnected. If I take, this is an A4 size document, if I fold this in half, this becomes an A5 size document. This is what we typically use for commercial transactions in most of the world. Actually, all of the world but the United States and Canada recognizes this standard. This is what we use for commercial, letters and so forth, bank statements. This is the standard size postcard in most of the world. And this is the standard, this is called A6. This is the standard size passport in most of the world. So these three rules govern DIN 476. And I just named these rules. And it was introduced in 1922, and the economic ministry in the Weimar Republic at the time declared it to be binding for all government transactions immediately thereafter. One of the first government institutions that adopted this standard was the German postal system, also in 1922. Soon thereafter, the rail system did as well, and they were nationally run and managed. And essentially what they did is they helped advocate for the use of this paper standard throughout Germany, and indeed ultimately also throughout much of the rest of Europe. The developer of this standard, the guy by the name of Walter Postmann, did so, as I noted, with the intention in mind of rationalizing the modern office. That is to say, he wanted to promote time, money, and energy-saving working methods within offices in Germany and around the world, and he believed that paper could help one do so. What this diagram shows, this is actually derives from a company that he worked with starting in the mid-1920s. It was called Fabriknorm. And essentially what they did was they developed standard dimensioned office furnishings that all used DIN 476 as its basis. They were all dimensioned with A4 sheets of paper in mind, for example. And a lot of that has proven extremely successful. Over the course of a couple of decades, literally hundreds of standards, DIN standards, emerge which base themselves directly on this paper standard. So, for example, there are envelope standards that are based on DIN 476, and that's so that you can slot a document into a standard size envelope and not waste much space. There are also graphic design standards that are based on that. And this is very useful for commercial transactions because it's what allows, it allows you to basically fold a document so that the envelope of the addressee appears perfectly in the window of a window envelope. Binder sizes are based on DIN 476. So, for example, so that you can slot them very comfortably into the binder. So are sleeves, transparent sleeves, and so on and so forth. And in fact, what the dream was ultimately to standardize and systematize the entire office using this one standard as its basis. Now, as I mentioned, it proved extremely successful. So much so that today it's only the United States and Canada that don't recognize this standard. Everyone else in the world does. One can say, moreover, that I think standards institutes around the world have always tried to duplicate the success of DIN 476. That is to say, they've always tried to standardize their respective industries in much the way that someone like Postmann did both the paper industry, but also the paper product industry in many respects. Incidentally, it was a very powerful piece of advertising for the German Institute for Standardization. Now, one architect who was very deeply influenced by this standard, DIN 476, is a guy by the name of Ernst Neufert. And Ernst Neufert is one of the main figures that I'm exploring in a book that I'm currently writing and completing on standardization in architecture. So who was this Ernst Neufert character? So Ernst Neufert was part of the first class that studied at the Bauhaus. He studied there in 1919. And then he became an architect in the office of Walter Gropius. And he became the project architect on projects that you're probably familiar with, like the Bauhaus School in Dessau. After completing that, he became a professor at the successor to the Weimar Bauhaus. It's called the Staatliche Hochschule in Weimar. Actually, the successor to that hosted me during my stay in Germany this past year. And then after World War II, he became one of the leading industrial and commercial architects in all of Germany. This, what I'm showing you here, this is known as the Quelle Versandshaus. Quelle is actually the leading manufacturer of prefabricated homes in Germany. They're now insolvent. They don't exist anymore. And until recently, this was the second largest vacant building in all of Germany. He also finally, during the course of World War II, worked for Albert Speer, what some people call Hitler's architect euphemistically. And I'm going to be talking about the importance of this experience to Neufert's engagement with standardization generally and paper standards more specifically. Now, Neufert is probably best known today for writing this book. It's called the Bauentwurfslehre. This is translated in English as Architect's Data. Anyone here familiar with this book? It is probably the most influential standards handbook in the world. We don't use it here because it's based on metric units. It's incredibly useful, however, I think, even if you don't recognize the metric system as we don't here in the States for a variety of different reasons. It's now in its 40th edition, and it was first published in 1936. So Neufert wrote this book. Again, it's gone through lots of editions. And what is the purpose of this book? It essentially offers standards and recommendations about construction, about energy and time and space-saving design solutions. And it is also a catalog of examples of building types. There are lots of sample solutions for example, if you want to design a single-family home, for instance. Now, what Neufert is less known for are two standards, DIN 4171 and 4172. And arguably, the influence of these two standards on the history of architecture is probably at least as great as that of this other book itself, this Architect's Data book. The history of these two standards is also intimately tied in with the history of that book, as I'm going to discuss. Now, Portsman's DIN 476, this standard sheet, was the basis for DIN 472, and I'm going to talk about that link. DIN 4172 is a system for coordinating the dimensions of building components, essentially. And my argument, what I'm going to talk about today, is how this came from this, and why it's important to understand that particular genealogy. How did DIN 4172 come about? Neufert's experience at this school here, the Staatliche Bauhochschule in Weimar, the College of Building, it's like an NYIT in Weimar, was extremely instrumental. This school was located in this building here. It was designed by Henri van der Velde around in the first decade of the 20th century. And Neufert's pedagogical philosophy, I think, is captured in this quote. He said, "It should be borne in mind that spaces at the Bauhaus, this school that I taught at between 1926 and 1930, served a different purpose than in the past." Excuse me, excuse the typo. Earlier, ateliers were intended for individual professors. Today, the ateliers on the upper floor represented interconnected workspaces that contribute to the seamless and efficient completion of tasks. So one of the important things that they try to teach at this school were essentially time and space-saving working methods. And they did so in a variety of different ways. One important way was through a course they developed called Rapid Design. And in a course called Rapid Design, you were essentially taught in how to visualize and ultimately solve an architectural problem in under 3 hours. That was what you were taught in the course, and then it was assessed by the professor, and here's an example of sample work that came out of that study. A second thing they did is that many of the students who studied there, and it was a 3-year curriculum, had to go into what they called an active building atelier during their last year of study. And essentially there they devoted themselves to design build projects. And two of the buildings that came out of that are still standing today, and you can find them at the University of Jena, which is near Weimar. Now, what I found fascinating through my research is that at this school, students were also not just taught subject matter, but they were actually instructed about precisely what tools they should have and what specifications they could conform to. So what this says here is that this drawing table is basically ideally suited for a DIN format A0, poster size A0, which means that the dimensions of this desk are based on DIN 476. The paper is rests in a roll. The plans are ordered in a very clean fashion according to objects. They're found in this desk drawer, which is easily reachable by one's hand. And what Neufert was thinking was that by using these systems where the dimensions, desk dimensions, were established with these organizational systems in mind, with these office furnishings and paper standards in mind, that in so doing the students were going to ultimately save space. This whole interest in paper standards and the organization of offices endured afterwards. The school closed in 1930, and in 1931 there was an exhibition in Berlin, and it was devoted to, partly to efficient office furnishing systems. And one of the things that Neufert did for precisely that purpose is he wrote a review kind of extolling the virtues of these document storage systems that were all based on, again, DIN 476, these standard dimension documents and formats. He writes, "The visitor receives a good introduction to the area of office technologies in the special exhibit by the Committee for Economic Office Administration. Here he is giving a visual overview of the activities of a modern office and the logical structure of the workplace. The letterhead is no longer a random fallow ground, but a clean playing area that follows exact rules derived from the grid of the typewriter." Now, in his book, The Bauernfortslehre, and this was first published in 1936, he also talks about DIN 476 and paper standards. And in fact, interestingly, paper standards appear in almost the very first page of the book, which seems odd, but isn't. He, in fact, introduces the reader to these three, to DIN 476 and the different advantages that it affords. He does so in the very beginning of the book. And then he writes here that standard formats build the foundation for the dimensioning of office furnishings, essentially, and document storage systems. And they are also determinative of the dimensions of entire rooms. And this is very interesting. Again, the book itself is partly organized typologically. This particular page that I'm showing you illustration from derives from a page that's devoted to libraries and bookshops, presumably. And here, essentially, what he shows is how you could take a standard dimension book based, for example, on DIN A4, and from that derive a dimensional system that could regulate bookshelf heights. And then from that, one could also ultimately figure out room dimensions as well. So beginning with something small, one small dimensional unit, one can develop a much larger interior plan. In the pages devoted to office buildings, he offers us essentially the same visual graphic argument. He begins with here, interestingly, he begins with filing systems, and the source for the standard dimension filing system that he's showing us as readers comes from Fabriknorm. This is Walter Postman's company. And using that as his basis, this is actually a catalog from Fabrik Norm of Walter Porstmann's company. This is a page from this book, the Bauentwurfslehre of 1936. And what he shows is that you could use the dimensions of these standard dimension furnishings, which are based on standard sized sheets of paper, and use them to develop space-saving office solutions. And he shows that in this plan, for example. Now, there was a problem with DIN 476, with standard-sized pieces of paper and using them as a basis for trying to standardize or coordinate the dimensions of entire rooms. He says, much later, in the Bauentwurfslehre, in this book I wrote, I tried to distill the DIN standard sheets into a comprehensive and coherent way, In so doing, I found out daily that an overarching coordinating system that simplified construction and comprehension was missing. Essentially what he was saying is that I could use standard-sized documents to figure out the floor plan of an office space or of a library or of a bookstore, but I can't use it to figure out, the size, that a bedroom should be. I can't use it to figure out what a museum, the space of a museum ought to be organized like, or an athletic facility. In other words, its application in architecture, he found, was somewhat limited. And what he was after was a more holistic language that could coordinate all building types, both purpose-oriented and also monumental. Now, Germany's National Socialist government gave him the opportunity to address precisely this problem. So they came to power. Hitler was elected chancellor in 1933. He became acquainted with this young architect, Albert Speer, actually at roughly the same time. Speer joined the Nazi Party pretty late. Neufert ended up working for this guy, who actually functioned as the general building inspector for Hitler between 37 and 41, and then in 1942 actually became one of the most powerful government ministers in the whole Nazi apparatus. Speer gave the Neufert sort of the framework with which to develop and elaborate these ideas. And through that experience, I'm not going to talk about it here, Neufert actually exercised a pretty considerable impact in many sectors of the economy of the Reich. Within Speer's office of the General Building Inspector, there were three divisions. There was basically a design division, there was an accounting division, and there was a construction division, or construction management, you might say. Neufert worked in the construction management division. And there was actually a department called the Neufert Department. And that existed between 1938 and 1941. This is a letter to Porstmann, but I'm not going to talk about it. What were the results of this work? One of the most important insights that Neufert derived through his experience working for Speer appeared in the Social Housing Journal in 1941. It was a social housing journal sponsored by the German Labor Front and Hitler's housing commissar by the name of Robert Ley. And the essay was titled the Octameter System. Now, what does the Octameter system refer to? The claim was very simple. The argument was, Neufert's argument in this essay was that the metric system is good, but meters should not be divided into tenths, but rather eighths. And there are lots of advantages to dividing the meter into eighths rather than tenths. as I'm going to discuss. That's why he called it the octameter, because it was an eighth of a meter. And there are other scholars who've actually discussed this, I think, in great detail. Probably the most essential advantage that the octameter afforded is that it approximated, if you took let's say 2 times 1/8 of a meter, 2/8 or 1/4 of a meter, you came very close to the dimensions of what was already the standard dimension brick at the time. It was called the Reichsformat. And so essentially what he said was that one should pick the octameter, one should reorganize the construction industry, and in particular the construction of housing, where brick was most dominant, around the octameter, so that one could then one could then use it to standardize brick dimensions. And I'm going to explain an example, one of the advantages of this system. Essentially, what he said was that brick sizes, ideally, under the current system, are close to a meter if you take 4 of them side by side. But if you base a new standard brick dimension on my system, what he called the octameter, then essentially you can create bricks that, with the mortar joint, will measure 25 centimeters in length. If you take 4 of them and you place them side by side, you get a meter. So essentially, one of the advantages that it affords is that it eases the communication between the designer and the builder by allowing a construction worker, say, to measure distances, for example, using brick units rather than by referring to a drawing. And as we know, many builders don't look at drawings, so it proved advantageous in many different respects. I'm not going to go into the differences between the octameter brick standard that Neufert introduced and what came before. They were fairly close, but essentially he tried to introduce a system that would yield, that could yield whole units. And the thinking was, as well, that one could then use the mortar joints to actually do space planning on the interior as well. So you could actually not only develop standard dimension furnishings based on the octameter, but you could also use the system to actually dictate where objects would be organized in space in the interior. So this octameter was intended to serve a very important pedagogical function. This is an example, this is an illustration from a book that introduces a mason to octametric bricks. It came out after World War II. And it essentially shows how this 12.5 centimeter module could be used to organize the layout of bricks on a construction site. Now you might be asking, how does this relate to the whole issue of forced labor and slave labor in Nazi Germany? Well, there are lots of different issues. First of all, one has to remember that the labor population in the concentration camps, for example, was extremely diverse culturally. They spoke lots of different languages. And so this system addressed itself to that problem. Second, and I think this is actually the more important point, the biggest fear that that both the Nazi government and a private industry, private companies they contracted with had about the use of slave labor and forced labor is that they were given to sabotage. If you're a prisoner, you have every interest in trying to make sure that Germany's going to lose the war, right? You're going to try to slow things down, and you're going to try to also make sure things don't work. And it would have been the rational thing to do, because their living conditions were abysmal. There was mass hunger, there was disease, summary executions. Remember, many of them were were living in concentration camps that were operated by the SS. And one of the things that the octameter did is that it introduced it helped ensure that it made it easier for one to inspect a building to ensure that there was accuracy in construction. So they didn't actually realize or get to make use of brick sizes that were based on the octameter during World War II, but they did something already quite similar. As you can see here, the dimensioning, the spacing of the bay widths here was essentially dictated by something very close to the metric unit. So essentially, you could very quickly ascertain whether whether someone was working with proper tolerances in laying bricks by seeing whether the mortar joints lined up with these wooden posts you see. What's more, the standard dimension brick sizes, according to the logic of the octameter, also dictated window widths and doorway widths as well, because the thinking was, well, it's a big waste of time to cut a brick in half, so let's try and work with bricks as whole units instead, and use that to organize the entire construction site and individual building components as well. So the compelling logic of these brick dimensions will simplify the challenges associated with the recalibration of brick factory practices in annexed territories. The metric system was already in wide use in Europe at the time that this system was introduced. What came before it, the bricks that Germany was using before this, were actually based on imperial units, what we use here in the United States. So the thinking was that it's more international, hence, when we occupy these new countries, they will assimilate and be able to reconcile themselves to our system more readily as well. So here in this book, for example, he showed an illustration of all the different brick dimensions that reigned throughout much of Europe, and he was going to replace it with just one, in the name of saving money, energy, time, as well as guarding against issues like sabotage, as I mentioned earlier. Now we call it quality control. Then they called it being free of mistakes, Fehlerfreiheit. On account of its compelling advantages, the brick format that I am proposing will be adopted as the standard format in all countries which utilize the metric unit. If a building is planned according to the octametric system, the contractor only needs an octametric leveling rod in order to organize the entire building, the axial distances, window dimensions, doorways, post partitions on a rapid and mistake-free basis. So it was an entire building system that rested itself on an assumption about a standard dimension or a proposal for a standard dimension brick. So essentially, just as Walter Postmann used paper to try and regularize and standardize the dimensions of office products, Neufert wanted to use a brick size to standardize and regularize building components, furnishing systems, and space planning. Now, how was this system used in practice? The octameter was introduced to address Germany's housing needs and to expedite them rapidly. In practice, however, that part of it was never realized because in 1941, Germany started to lose the war, and they realized that they had to start focusing exclusively on the war effort rather than diverting their attention to housing lest they lose the war. So attention shifted away, priorities changed. However, the octameter did get utilized on a limited basis during World War II. One of the entities that made extensive use of the octameter was the SS. This is actually coming from this same essay, the octameter system. For these persuasive reasons, a series of very progressive industries have used this system for the development of design. So, for example, the SS built an entire furniture fabrication system on octametric norms. And it did so primarily to facilitate settlement in the Eastern occupied territories. As you probably know, Germans waged an ethnic cleansing campaign in the Eastern territories. Millions of Jews were killed in the camps as well as others. Part of the project, however, was also to try and settle ethnic Germans in countries like Poland in order to help give birth to a more racially pure society. These were furnishings intended for SS officers and their families, which partly explains this sort of alpine aesthetic that informed some of these designs. These were furnishing systems, and they were all based on octametric units. They were also space-saving, such that they could, the entire dwelling unit, as well as the furnishings, could be collapsed into a giant volume like this, presumably placed into a freight car and shipped out east, unloaded, and then reassembled on an expedited basis. And so here in this diagram, and this is coming from a publication by Neufert, he was showing many of the space-saving advantages that the Octameter afforded for shipping purposes. This is also a photograph that appeared in one of his books. These furnishings were designed by this guy, A. Zwink, and he was actually an SS officer. And many of these furnishings were fabricated by prisoners, I believe, from the Dachau concentration camp. And I think what was also important is to show that these were fairly easy furnishing systems to assemble, that one didn't need nails, and that they could also be presumably disassembled as necessary. In some ways, it was almost a proto-IKEA. There were the Octameter was also used for the purpose of standardizing the dimensions of some of these nascent domestic technologies like refrigeration and electric ovens and entire kitchen systems, kitchen appliance systems. This was for the city of Berlin, but they were not brought to fruition. He believed that one could develop entire floor plans using the Octameter, and here he shows, one point. These are all either multiples or fractions of the Octameter, right? They're all multiples of the Octameter, all of the dimensions in most of these rooms. Now, after publishing this Octameter essay, Neufert really thought he hit on something big, on almost a universal language of design that could span many different building types, not just libraries, not just offices, but housing and other needs as well. And the 1944 edition of this book, the Bauernforst letter, reflects precisely this belief. So, for example, he rewrote the dimensions of the standard dimension man so that it was compatible with the dimensions that the Octameter allowed. So you can see here that this human being, this so-called well-proportioned human being, was actually 1.625 meters, right? And it was actually revised from a slightly higher number that was not compatible with the Octameter before. He touts the advantages of this system in the 1944 edition of this book. He rewrote the dimensions of standard dimensioned model floor plans for bedrooms as well in the light of this innovation. And he also, I think most importantly, rewrote the pages devoted to office systems and offices as well. This should be a familiar image from the one I showed you before. That was from the 1936 edition of the same book. It's the same illustration. On one page, however, he can change the dimensions ever so slightly. What was important here is, if you remember, If you recall, these are standard dimension furnishings based on Postman's system. They're also based on the dimensions of a standard sized sheet of paper. They're based essentially on DIN 476. And in a very subtle way, what Neufert showed on this page is that utilization of the octameter, of this octametric system of measurement, did not preclude recognition of DIN 476. So, for example, DIN 476 dictates this desk size. However, the octameter dictated the bay widths. And essentially what he was saying was that the two systems were compatible. This is a very important principle because one of the distinguishing characteristics of how standards and standards developments operate in most of the world is that, outside the United States, is that outside the United States, when a new standard is introduced, it cannot contradict the claims of another standard. So you can't have two different standards that, claim two different assumptions for what the dimensions of a sheet of paper, let's say, should be. They call it being free of contradiction. They all have to harmonize and synchronize with one another as a system. So he was essentially documenting that his worked with DIN 476 in the pages of this book. So, and he states it, and he does so here in this model floor plan. Now, World War II ends in 1945. Germany is devastated. Many of its cities are decimated. Neufert, however, was largely unaffected by the denazification proceedings that the Allies undertook. One can offer a variety of different explanations. For example, that some people may have interpreted his work to have been of a technocratic nature and hence not political and hence not criminal. Whatever the case, what is important to bear in mind is that his influence endured after World War II. And in fact, he only grew more powerful after World War II. Why? Because essentially, the people who were in power in the construction and in the architectural industry during World War II, they all remained mostly, for the most part, in power after World War II. It was a very powerful network, and they continued to influence the activities of organizations like the German Institute for Standardization. Its board, its a construction committee, still continued to be populated by people from Speer's office, from people from the office of Robert Ley, the German Labor Front, and from the Organisation Tod, which was responsible for the vast majority of construction-related projects throughout the Reich. And it was a very, very tight-knit unit. Now, Neufert continued to advocate for the use of the octameter after World War II. And this battle played itself out in the pages of magazines like Bauwelt in Germany. And so this person is saying, this is a cartoon, says, you must, 1.25. Another person was saying 1.64753. Another one saying, the octameter of all countries, unify yourselves. It was a big debate. Everyone agreed that they needed a standard unit around which to regularize the dimensions of building components, but they didn't quite agree as to what system they should use. Ultimately, however, Neufert prevailed. And in 1951, his proposal became known as Baunormung im Hochbau, which is basically a system of standardization for Hochbau, basically architecture and buildings. Out of this effort came, the basis of it was this standard here, DIN 4172. And what this illustration shows are all of the other standards that essentially descended from DIN 4172. So there are standard known as 1811, which governs space planning. That's based on the octameter. There's a standard for standard for kitchen and bathroom dimensions. That's based on 4172. There's a standard for brick dimensions. That's based on 4172. There's even a standard for ceiling heights. That's based on DIN 4172. So there's an entire building system, and it was expressly conceived with this standard in mind. Now, Walter Postman, the guy that introduced these standard paper sizes, and Neufert knew each other. And in the early 1950s, he published this, an essay, basically touting the benefits of the standards. And here's what he wrote. Paper standards build up from the standardization of the area of DIN 476, standard size sheets of paper. The building industry, however, has recently introduced a dimensional coordination in building construction, DIN 4172. This standard brings unity to the proportional system. It also brings unity to the fragmented series of relationships and gradations. Here we would again have an important basis for the ordering of space. So ultimately, the goal was to standardize an entire living environment using one dimensional unit. Again, Germany was decimated after World War II. Constructing and rebuilding on an expedited basis was of the utmost urgency for a variety of different reasons. And municipal authorities looked, of course, to DIN 4172 in particular in order to develop specifications that would help expedite rapid reconstruction throughout Germany. And one of the things that they declared was that in order to gain access to municipal funds for housing reconstruction, essentially one had to recognize these standards. First and foremost, DIN 4172. And this actually speaks to one of the important mechanisms that many countries use in order to advocate for standards. They use economic incentives, and states will use their own market influence in order to help institutionalize their use. There are probably 4 million plus housing units in Germany that base themselves in one form or another on DIN 4172. Many times this is not intentional. The standard dimension brick in Germany until the 1990s was based on this standard. You didn't find any other size in Germany. So in a sense, by using it, one was also obliged to recognize some of the other standards that governed window dimensions and so forth. And this proved particularly true in the housing industry. In subsequent decades, there emerged a octametric grid system, and essentially part of what it did was it helped institutionalize the use of the octameter in educational settings as well as in professional settings. In 1953, the DIN 4172 was adopted in East Germany. In East Germany, this standard had even bigger influence because it was legally binding. Standards in East Germany were not voluntary. They were actually legally binding. It was like a criminal act if you didn't recognize their terms. And this is a 34th edition of this book. I'm not exactly sure what the date, but it's definitely appeared in the last 20 years. The octameter continues to figure centrally in the book. This is an octameter-based grid system. And one can imagine that the very design of the designer, the very conception of the designer, owes something probably significant to these new systems of dimensional coordination that took root, in particular in Germany after World War II. This is a this says here a floor plan using as the modular basis basically Octameter, the Octameter grid. Now, to return back to this this juxtaposition, as I wanted to emphasize, or that I introduced at the beginning, essentially, in many respects, Neufert accomplished for architecture and the construction industry precisely what Porcelain did for the office industry. That analogy is a little bit limited, however, because while this standard ultimately got picked up by the ISO, the International Institute for, basically the international standards body, this one never did. So its influence proved limited. What I do want to emphasize, however, that the story of the history of standardization in Germany is not one that one can begin with Nazi Germany alone. In fact, as I'm trying to argue here, standards that came well before the start of World War II, this one came out in 1922, were also important. And both of these standards, I believe, participated in a process of rationalizing, which is also to say reorganizing architectural work in very profound ways. It's a history that perhaps began in the 1920s, but it was certainly went into high gear and amplified in many ways and spread into across lots of different disciplines, including architecture, under the Nazis. And one of the fascinating paradoxes for me is that the influence of many of these standards only grew after World War II, when in West Germany, for example, democratic institutions were reestablished. Thank you very much. Yeah, absolutely, my pleasure.
Thank you. Thank you, Nader. We'll have some open to questions. Are there questions? We always like to start with our student body. Any questions? They're always slow. Questions?
Was it comprehensible? Some of this stuff is, it's not that Americans aren't familiar with some of this material. In fact, Germans weren't familiar with some of this material. So I hope that you were able to follow the arguments. Yes?
My question...
Could you speak up so other people...
My question is related to how countries besides the U.S. and Canada list their products, or does Germany have something like UL listing or CSA certification on a national basis?
Well, you asked a good question. The question is does Germany have UL listing on a national basis?
Yeah.
I'm going to confess I don't know those terminology that well, because I'm a historian and I don't unfortunately I've never been a practical guy, so you'll have to enlighten me on it. But I think I get the gist of what you're saying. In Germany, you have one of the key differences is between the standard system in the United States versus the rest of the world is that in most of the world there will be one institute that is tacitly recognized as the kind of state-sanctioned standards institute within the country. In the United States, there is one federal body called ANSI, which can accredit standards organizations, but it doesn't actually issue any standards. So there are many different standards organizations in the United States, and very often they will contradict one another. Now, this is starting to happen in Europe with the EU and globalization. I got to speak with a gentleman that Matthias introduced me to, who worked with us with NYIT students in Berlin. He laments the demise of this standard in Germany, because what he says now is that, are two things. First of all, the number of choices is overwhelming. Second of all, the level of miscommunication that will take place between fabricators and manufacturers and architects is profound. You request one size, brick size, from a manufacturer in Brussels, and in the mail you get another. And then you complain and they expect you to improvise. So right now, Europe and many European countries are at this threshold moment where, like the United States, they're increasingly globalizing. The level of choice that they have is growing. The complexity of any building project is growing exponentially, where you're dealing with countless thousands of components. And yeah, I think under these circumstances, particularly some of the older architects are saying, you know, I wish things were simpler, because in fact, one might get a better quality product in the end. Sorry? Okay. Yeah, yes, Behan.
Mr. Vossoughian, thank you for this very informative lecture. One question I have is, why was the Canada and United States not following? Why were they not following the standard paper size? Do you know?
I think it's because we never adopted the metric unit. I think that's, I mean, Canada has, so, you know, I'm sure it's a more complex answer to that, and I can't give it to you. Standards, really, I've learned, are tools through which, historically, what they function are, they're tools through which countries project their economic interests. So what's at stake in why we haven't adopted it, I think one has to offer an economic answer, it's a geopolitical answer, and I think part of the story, at least with respect to the United States, is that we still use imperial units. And so, and it doesn't translate well, despite the advantages it brings. Industry also plays a huge role, private industry and the voice of private industry. Yes, yeah. Oh. Go ahead, Judy, please.
Great talk. Thank you very much. There's a lot of information I didn't know before. I don't think this is on. Is that better?
Yeah.
But so many questions arise.
Mm.
Like, I'm curious to know where your research is leading. Like, there was where the research is leading. There was one question about implementation. It had to do with UL listings, and it had to do with the desirability of greater uniformity and greater imposition and adherence to standards.
Right.
But then there's also the kind of social and economic and political aspects to the standardization of standardization, which I think you've only touched the iceberg of,
Yep.
because these are fascinating issues
Yep.
and clearly have implications for the way that folks do business today, as well as the way that
You
the
raise a-
Germans were doing business in the 1930s.
You raise a great question. When we went to ASTM last week, they said that, you know, right now this Trans-Pacific Trade Pact is on the table, and, you know, they're eager for it to be ratified because it's going to bring the United States lots of economic advantages. I said that can standards do anything to protect workers? You know, H&M, for example, we know about the story in Bangladesh. You know, H&M contracted with a company in Bangladesh that was using essentially forced labor, slave labor, to manufacture garments. They were working in a precarious building. It collapsed. Many people died. People said, H&M, why didn't you do anything? They said, we didn't know. We contracted with them. And so one question I asked ASTM is you know, can these standards organizations do anything to not just uphold quality in the product, but also, and not just efficiency in the process, but also uphold some idea about, you know, the rights of the worker. They said that's not our job, that's the job of private industry, and it's the job of nation states. And so I think there's a major blind spot in all systems of standardization in the United States is that they don't do anything to ensure or to guard against labor exploitation and super exploitation.
But is it possible there's something endemic in the imposition of standards that has a willful blind spot to that? I mean, it was designed in part to ensure that slave labor would be as productive and efficient as possible to the folks that were enjoying the benefits of that labor.
Right. I don't think there's anything endemic to standardization itself. I actually think that, well, I think that, I don't think that, well, let me rephrase it, I'm sorry. I don't think that it's one can ask that question today because we live with standards everywhere we go. We can't simply say, I'm not going to live in a world of standards, because they're literally everywhere. They permeate the fabric of our lives. And so my argument would be that we actually have to develop an expanded understanding of standards and standardization that deals with the problem of exploitation that takes place in this age of globalization.
I have a question. I'm happy to live in a world where I defy standards, as you might expect. I have to say, I've learned a lot, but I must say I'm going to be just the Judy most people know. Thank God for Corbusier and the free plan. I mean, really and truly, for me, this notion have been very appropriate at the time in Germany. When did the Octameter start, by the way, 1940? When?
42.
42. So
Well, I'm sorry.
in France, at the time, the promotion of the Villa Schwab, 1925, is concrete bearing wall building. 1925, comes the Villa Schwab with Villa Garches, which is the complete rejection of standardization in terms of the free plan, walls falling where they may fall, and not dealing with the grid being the drive. There was a grid of columns, a spatial grid. So when I think of this period, I'm thinking, because I'm extremely visual, if one applied that set of standards, there'd be no Khan in Dhaka, there'd be no Chandigarh, there would be, if the world, and I'm not talking about the standards themselves, if all people operated with a set of standards, it scares me because it precludes creativity. And certainly in post-war Germany and during World War II and the goals of the Nazis, it kind of made sense that this would be useful to them. But and you know me well enough to know that I've certainly used the Sweets catalog in America, the standards, to look up various things. But I certainly, what I kept thinking while you were speaking was, this is very interesting. This is a precursor, putting aside much of that, for what I understand these digital software programs have BIM to be. Okay, push a button and that's your stair, and push a button and that's your window wall. And as you know from my position on this is I just don't buy it.
I'm a historian, and I'm dealing with the same issue of
No,
BIM, but I'm doing it through...
No, I know you're a
So I'm glad
historian.
you picked up on that, because that's precisely what's at stake in this book.
But what I'm trying to say is, even as a historian, you have to understand you've picked a subject matter, and that's good. But within the realm of students studying architecture, that there's an understanding you can't, for me, standards become crutches. So I'm just curious, what's your reaction to that?
Well, we know two different Le Corbusiers, because the Le Corbusier I know was also the architect of the modular man.
Well, yeah, but is his modular man the same size as Neufert's modular
Actually,
man?
Neufert writes quite
curious.
expressly that the octameter doesn't preclude recognition of the modular man. And
He would have been in big trouble if it did.
I don't know. I mean, I think that I don't.
But I want to know what your, the feeling of standardization. Is it a crutch in the world of design and for architects who are making buildings?
The dean was saying that is it a crutch? Are these standards a crutch in the world of creative thinking? I would argue that we're always thinking with standards, even when we are blind to them. Precisely, the power of standards and standardization is that we allow ourselves to forget that they don't exist, and yet they condition everything they do, including, for example, when you think about right down to the sheet of paper. And I think that to believe that somehow we can avail ourselves of this influence, I think I don't think it's possible. I think that we live in a world saturated by standards, and it's not a question of standard or no standard. It's a question of how standards, especially if you're going to live in an industrialized society. Does that make sense? That would be my answer. Naomi?
Just to add to that, the comments that have been, I talk really loud.
Not loud enough.
Nader, that was an amazing lecture. Thank you so much. And my first job when I was in third year was in Berlin, and they handed me that book. So it brings back memories. I guess my question is, when you brought up the slave labor and just to tie all of it together with the standardization and the construction industry, my core question is, how much of this standardizing reinforces, or cuts our intuition? Because, you know, when you start to standardize something, it becomes part of the way you appropriate it. So does that become the way we as humans deal with the creative process in terms of our intuition? Or does it kill our intuition?
See, I think that it's a false opposition, to be honest, this distinction between, you know, creative, less creative. I mean, I think that there are ways, you know, that I think the best we can do is hack. We can be hackers. You know, we can take this vocabulary and we can almost, they can be tweaked, they can be appropriated, they can be manipulated in creative ways. But I don't think that one can escape them. Do they impinge upon intuition? I think it's so hard to judge. I mean, I think that's why the title of this talk is The Design of Design, because part of what I'm talking about is like the very DNA of practice. Like, this is part of the DNA of practice. It's like, you know, how do you think about contemporary practice, particularly in a lot of parts of the world, apart from these systems and apart from these standards? And I don't think it's possible to do so. And I'm less familiar with the American system, but I would guess that they are extremely influential as well. It's part of what it means to live in a kind of industrialized and globalized society. It's and one has to remember that you know, one of the important functions that standards have always served is that they actually, one of the things they do, they help keep wages down and costs down by simplifying tasks and responsibilities according to any one individual. And that also goes for the architectural profession. What I didn't talk about is that there were many prisoners, concentration camp prisoners, who were also architects whose labor was being exploited. And these standards that were introduced were also introduced expressly for the idea in mind of trying to make it easier to dispense architectural knowledge and to make it more readily accessible to a broader audience. Whether it impinges upon intuition, I can't answer, but I feel like we can't answer because we don't really have a choice in the matter. We live with them, we work with them.
Yeah, that's what I kind of meant, like you're designing somebody's intuition. You know what I mean? It's kind of like a controlled, we're going to make it really simple for you. It's just going to become intuitive. You grab the brick, you stack it next to the next one, and you know it will fit. So it's kind of like turn your mind off, right? Like it's a double-edged sword, right? It could be that, and it could be the reverse, which is what you answered.
I think it can be both. You know, I think it can be both.
We have to move on, but David has a question.
Two very quick comments. I mean, among the many subtopics that I would be fascinated by seeing developed in your work is designing with grids. Because from Durand and naval architecture's exploitation of grids to make it easy to build quickly for military purposes to the Froebel block system, which Frank Lloyd Wright and Le Corbusier both built upon. And that's, you can draw, I'm sure, a fairly straight line from one to Neufert.
Right.
And so that's very, very interesting.
Mm-hmm.
The other thing I just wanted to mention is that 1 week ago in this room, Esteban Baita spoke about traditional Japanese design. And the tatami mat system is another kind of set of standards which govern a unique and remarkable language. And the conversations we had about that kind of standardization were very different from the ones we're having tonight.
Yeah, no, it's the tatami mat is it's just, you're absolutely right. It's very analogous in terms of the not the execution, but in terms of the spirit of the project.
We can't go on too much longer, but it's a very interesting conversation. And I have two more of my own comments would be, I think we're talking about a profession which the profession relies, like all economic endeavors, on efficiency and getting the job done. And we're talking, in my mind, about this conversation within that environment. But within architectural education, I would have to qualify all this to say to the student body that's here, hack away.
Yeah.
Because I think your answer was a good one, because it brought to mind, of course, what my mentor and certainly recognize. I just got the book Reckoning with Roe by Peter Eisenman, saying that this was the greatest architectural thinker of the last part of the 20th century, or major part of the 20th century, said always, take virtues, make vices into virtues and limitations into freedoms. So for me, standards are vices and limitations that are useful, incredibly useful, to work with to come out into the world of free thinking. So for me, that could be another kind of a conversation. The one other comment I make, like David, different, is that I was thinking these standards, they never address the resolution of how you compose the exterior skin, except talking the materiality of a module,
great.
which is very interesting.
It's a
Just,
very-
that's
He
an
has an
intuitive
answer to that.
thing.
No, the Octameter, that Neufert insisted that there was actually an aesthetic foundation for the Octameter as well, that it was actually created harmonious proportions. That's why he believed that you could use it for the design and construction of not just purpose-built structures, but monumental buildings as well. That, of course, was an extremely important distinction in Nazi Germany, the one being functional, the other one being artistic, and maintaining that separation. And he essentially said, no, this is a standard, but it's also aesthetically pleasing. It's not something I got to talk so much about.
One more question.
I think Bill,
I just had one
Is there a
quick.
student?
well, I know Bill had a question.
This will be quick.
Did you?
I had a question ultimately about the position of architect today. In ornament and crime, loss is not ultimately against ornament, but it's against kind of mass production and repetition, industrial repetition of ornament. I'm wondering if this kind of standardization is doing precisely what he was arguing against. I'm asking about loss, ornament, and crime, and his kind of argument based on the fact that we kind of losing, the profession of an architect is suffering from the kind of, repetition.
The junk space. Is that what you're saying?
Right.
And you're saying that's a risk. I think.
I'm wondering if you see a link between, standardizing process and this kind of argument of loss in terms of repetition, in terms of replacing thinking by repetition. This kind of discussion we have about post-parametric, when a kind of computation is replacing a lot of making a lot of decision. We see this in the studios these days when students can easily access, build objects that they can plug in their models and they stop thinking. And that made me think when you show the picture of how a bookshelf is designed based on a format. It didn't talk about how these bookshelves are spaced in the space so then a human can walk between them, right? It was designed by the format rather than a human being.
Well, I'll answer the first question. I think you're absolutely right that is a risk, and one could say that to be generous, postmodernism was precisely a critique of that tendency in modern architecture. I mean, we associate postmodern architecture so closely with commercial architecture today, but I think when reads like Colin Monroe's work, like Collage City, for example, that they were actually trying to confront how homogenous the world was becoming. The problem is that it's very hard to know how to position oneself, because as we know today, postmodernism has also become a global commodity through which one can help, facilitate the maximization of profit and lots of other things. I just don't think it's, there are easy answers, and that's part of what I'm insisting on in this project. There aren't easy answers,
I guess ultimately my question was, what's the fine line between standardization or any other method being an inspiring aspect of your design to being a driving force where you lose a lot of other qualities in the process?
Well, I'm not a practicing architect, so you could answer that probably much better than I could.
We have one more question. Does anyone have a question? Yes, Behan. Give Behan the mic, please.
Thank you. I think what's interesting is that they use square root of 2, which is actually an ancient Greek proportion, right? It's coming all the way since Pythagorean theories, and therefore, and many aesthetes and architectural historians have tried to define beauty using these proportions. Mm-hmm. So it's not really, didn't start in Germany and didn't end in Le Corbusier and vice versa. So I think that's another aspect. I mean, it's intriguing for me when you find the roots of this standardization system and then connect it to a political system. And I think then it becomes non-conclusive because whatever they discovered, it's just part of a process that started with the Greeks and the Arabs and the mathematicians.
See, I believe that standardization only began in the 20th century. I understand what you're,
But the proportion system started way back,
See, I think that the emergence of standardization has a lot to do with the emergence of the division of labor between the builders and designers, for example, and that certainly didn't exist in ancient Greek times. I also think that it has everything to do with the rise of the nation state and its ability to organize resources, and it has to do with a lot of forces, and that's why I insist that one has to historicize this concept of standardization, that I believe it's actually unique to the 20th century. In fact, all of these standards issuing bodies were all started in the first 2 decades of the 20th century for the most part. And I think they were responding to very specific issues, and I think it's important to understand them in that context so as not to mythologize them. I think that when we look at them, when we use such a broad, 2,000-year history in order to contextualize them, then we risk saying that these things are somehow, this process is somehow natural, almost instinctual thing, which I don't believe. I believe that there are very specific forces. I actually believe that standardization is actually very closely tied to the history of capitalism, and that the history of capitalism can help explain the rise of standardization in the 20th century. And in fact, I would also argue further that one can explain, I believe that one can explain, and I'm going to go out on a limb here, the atrocities of the Holocaust by way of the history of capitalism as well, that there were enormous number of profit gainers, profit makers in that camp infrastructure system, and that I think that's an important piece of the narrative that needs to be emphasized. So I think I would respectfully disagree. I think the 20th century, we have to kind of believe that there was somehow something different happening, and that can also help explain the political and economic changes as well.
Well, I must say this is a very provocative conversation, and we should have many more of these kind of conversations. I would go farther out on a limb, but I will defer to the end of the evening. So
thank you very much.
Thank you very, very much, Nader. It was a great talk.
Thanks, everyone.